Hello. Today I'll be doing two more questions on the topic of application vectors. Oh, that's weird. Two. Okay. Yes, so the first question says, a ship is traveling with a speed of 20 knots along bearing of 080. So 20 knots on 080 relative to the ship, and the wind is blowing from 3 310 degrees true bearing, and then it's going at 8 knots. Okay, and let I and j be units vectors for the easterly and northerly directions respectively, which is normally what we do anyways. By expressing the given vectors in component form, find the true speed and direction of the wind. True speed and direction. So I think we can draw it out first. So basically, the boat will be going like that, 20, because that's 80 from here, so there will be 10 here. And then it says from this true bearing. So if we draw that, it will look like this, because this will be 50. But it's coming from, we don't want coming from, we want coming, like going to. So this will be 50 as well. You can draw that in. That's not that long. Okay, so that's 50. And this is 8. This is 8. Okay, so we can do trig with this diagram if we want, but it says by expressing the given velocities in component form. So it'd be better if we do it with vector equations. So for the ship, we can make it into, well, 80 is just 10 degrees if we use trig. So it'll just be 20. 20 is, and then I is x, so it'll be cos 10 plus, because it's in the first quadrant, 20 sine 10. We've got the I and j. And then for the wind, which is relative to the boat, it will be 8. Well, that's 50, so this will be 40, so it'll be cos 40 I. And because it's in the fourth quadrant, y values are negative, so we can just do negative 8 sine 40j. So now we have to find this vector. So we just have to add those together. So wind true is equal to ship plus wind relative. And we don't really need to write it out because we can just add them together on the calculator because we can't really do it in our head. 20 cos 10 plus 8 cos 40. It will be 25.82 I, and then it'll be 20 sine 10 take 8 sine 40. That makes negative 1.67j. And that's it. Well, no, that's not it. That's a component form. We want to find the true speed and direction of the wind. So first, let's find the magnitude, which is the speed. So that's just Pythagoras. So it'll be 25.82 squared plus, well, we can write it like this, negative 1.67 squared. This will equal to, well, that is just this, so squared plus 2 squared. So around 25.90. Was it meters per second? It'll be knots. And for the direction, we know it'll look like it goes this way and it also goes this way a bit. So look like that. So now that's 25, that's 1.67, and this is theta. Well, then tan theta will equal to 1.67 over 25. So theta should be, we go inverse, find the other values first. So we're going to inverse tan 1.67 over 25.82. We get, oh, yeah, we get negative 3.699 degrees, which is just, we can do take 90 to give us both negative, so we 93.6, that will be 70 degrees true. So this will be 25.90 knots, 93.70 true bearings, that direction. Okay, let's do our next question, which is really long, but it's not that bad. So for the next question, it says the locations and velocities of 3 boats at this 0900 hours. So I'm just going to assume that's 9 o'clock, are given in the table below. Assume each boat moves at constant velocity. So there's a table. It says boat A, B, C. Location and velocity. It's negative 4i, negative 6j, 5i, well, that's just take 2j, negative 7i plus 4j. And then this is 20i plus 40j, negative 25i plus 20j, 35i, take 10j. Okay, so part A asks us find the position of vector A relative to B at 9 o'clock. So we don't have to do anything, so it's just these two. So we just add them together. So it's just 20i plus 40j take, well, actually no, it'd be A take B. So it'd be take 25i plus 20j. So this will give us 45i plus 20j. This question, that's part A. Part B says use your answer, wait, no. Find the velocity of B relative to A. B relative to A. We use V here because it says velocity now. So we look at velocity, A and B. So this time we use B to take A. So it will be 5i, take 2j, take negative 4i, take 6j. This gives us 9i. That will take, so plus, that'll be plus 4j. And question C says use your answer in part B to determine what time B and A will meet. B will meet A. So basically, A relative to B calculates how far A is from B, and B velocity relative to A is how fast B is approaching A. So technically, we can use these two vectors to find out how long until the vector will go over the path of the distance. So we can write an equation like this, 20j, because we're still using B and A, equals time times plus 4j. And we can see that time will equal to 5. So that is how long it took after 9 o'clock. So it'll be 9 plus 5, which equals to 14. So arrive at that time. We arrive at 2 p.m. So that's questions. That's part C. Part D says determine the position vector of point A where A will meet. Wait, what? Position vector of the point where A will meet B. So now we know when they're gonna meet. We want to know where they want to meet. So we can just use both A to find both A. So both A's position vector is this, and its velocity vector, we need a time on it because it's over time, changes over time. Well, no, we're turning it into a position vector because velocity times time is just distance. So we do that, and it equals 20I plus 40J. And then because t is 5 from our last question, we know that we can take 20I, and then it will take 30J. And this will leave us with 10J. So that's the position vector where will they meet. Now we're up to question part E. Find the distance between A and C t hours after 9. Find the distance between A and C. So that's literally just what we did with A and B, but with A and C this time. So we first want to find what is the position vector of A to C. So we can do this relative to C. And this we will get 20I plus 40J take 35I take 10J. So this will get us negative 15I plus 50J. And now we know A relative to C. We want to find how fast C is approaching A. So we want to do C relative to A. So C velocity relative to A. And this we will find this to be, we'll see, negative 7I plus 4J. And then we'll take negative 4I, negative 6J. This will give us negative 3I. Well, that's plus 10J. And that distance t hours. So we actually didn't even need the first part, but we wrote it anyways. We can use this for the next question. So find the distance. So this is the how fast they're approaching each other. So we can just write the distance is Pythagoras this. Well, we have to Pythagoras t times negative 3I plus 10J. So if we Pythagoras that, we will get square root. It'll be negative 3 squared t squared plus 10 squared t squared. This just equals to 109 t squared. And that's the distance, so we'll write kilometers. That's with t inside. So for question F, it asks us the time C will meet A. So we'll just use this one, and also this one. We'll just divide like how we did A and B. So negative 15I plus 50J equals T times negative 3I plus 10J. Oh, 10J. And T will equal to 5. So still 9 plus 5 equals 14. So they'll meet at 2 in the afternoon. So for G, asks us prove that all three boats will arrive at the same spot at the same time. So we can use numbers to prove this, but it's pretty logical. We just have to say that A and C will meet at, well, 2 in the afternoon. A and B will meet at 2 in the afternoon. Therefore, A and B and C will arrive, well, AB arrived at, maybe arrived at 10J, arrive at 10J, well, position vector at 1400. Yeah, we can test this with like where A and C will meet, but eventually we'll get this answer. So that's the answer. All right. Bye bye.